Our next section is going to be about absolute value functions. So we're going to do a couple things. We're going to first talk about the absolute value function in more detail. Then we're going to go through some properties of taking absolute values. Then we're going to jump into equations and then finally end with inequalities. So first and foremost, remember the absolute value function is one of our basic functions, and it really has that V shape, but it's broken down into two different pieces. So the first rule we have is when we take the absolute value of x, you get exactly what you have on the inside if what you have on the inside is greater than or equal to 0. If you input a negative number, like say the absolute value of -4, the output is going to be something positive. So what the second piece tells us is we have to change the sign if the thing we enter is negative. So using our transformations that we did a few sections ago, let's go ahead and graph y equals the absolute value of x minus 6. And remember, all this minus 6 does, because it's directly attached to the x, means it's going to move it horizontally. And because it's -6, it does the opposite of what you want. So we're actually going to move the graph right 6. So when we graph this, normally we started at 0, 0, and we had that V shape from there. But because we have to move it to the right 6, this is our y-axis, our new important value is going to happen at 6. And we still have that same exact V shape. Okay? And if you want the y-coordinate that this passes through, when you plug in 0, it would be the absolute value of 0 minus 6, which is the absolute value of -6. So it goes through +6 up here. Okay? So in the exact same way that we had a piecewise defined function back up here, we can do the same thing with this absolute value function. And so before, if you think about the graph of this, 0 was the cutoff point between switching over between these two lines. Now our new cutoff point is 6. So we can actually show that with this definition. So when we take the absolute value of x minus 6, we have two rules that have to follow. We get exactly what we started with, x minus 6, if what we started with was already greater than or equal to 0. Or if what's inside the absolute value is negative, we have to change the sign because this thing on the inside was negative. Okay? So it really creates, again, two separate lines. The first piece, we do absolutely nothing, but we can go ahead and add 6 to the other side of each of these inequalities. So we get exactly what we had on the inside if x is greater than or equal to 6. So that's this piece of the line. And then we have to change the sign, which gives us -x plus 6 if x is less than 0. And this gives us this other piece here. So you see it goes through the y-intercept at +6, and it has a slope of -1. Okay? So this is the rule that we have to remember. You get exactly what you have if what you have is positive. You change the sign if what you had was negative. So when we talk about taking the absolute value of any function, anything being on the inside, same exact rule applies. If what I had inside the absolute values was greater than or equal to 0, I get exactly the same thing. The absolute value does nothing. But if what we had was negative, I have to change the sign. So it's going to flip it. Okay? So let's go ahead and try this with a graph of a function. We're given the graph of f of x. We want to sketch the graph of it in absolute value. And then we also want to find the domain and range of both of these pieces. So starting out with this first one, we have the graph of our function. Let's go ahead and find the domain and range to start with. So for our domain, the x values that this takes on are between -2 and 4. So our domain is exactly that, and we can equal these two endpoints. And for the range, the lowest y value we have is -2. the highest y value we have is positive 4. So it happens to be that our domain and range match exactly. Okay. Now when I go to take this thing in absolute value, so I'm going to cheat a little bit and I'm going to just copy the picture over here. What ends up happening for the absolute value of this function, okay, think about how it's always going to give us something that is greater than or equal to 0, because the absolute value will never produce something negative. The minimum value it has is 0. So all of these y values that we have right here are currently negative. So think about currently f of 2 is negative 2. So when I take the absolute value of f of 2, I'm taking the absolute value of negative 2. It's in turn making it positive. So anything that falls below the x-axis is going to have to turn positive when I go ahead and put it in absolute values. So really, what we end up having is right around here is where that first point was. All of these pieces are going to flip up. So instead of going through 2, negative 2, I now go through 2, positive 2 for this particular function. So this triangle that was below the x-axis flips up and becomes positive, okay? So what this does is it doesn't impact the domain at all. The domain of this thing is still negative 2 to positive 4. However, by putting this function in absolute values, it does impact the range. So I now no longer start at negative 2. The smallest y value we have is 0, and the highest y value is 4. So our range actually turns to 0 to 4. Okay. Let's try a second one of these. Again, we've got a picture given for us, and we have all these points it passes through. What we want to do is we want to graph this in absolute value, and then we want to find the domain and range of both of these. So again, I'm going to cheat a little bit, and I'm going to duplicate my expression over here. And on this side, we want to graph the function in absolute values. Okay. We'll start with finding the domain and range of this. So our domain, the first x value we have is negative 2. The highest is 5. So our domain is from negative 2 to 5. And then for the range, the smallest y value is negative 4, and the biggest is positive 2. So our range is exactly that, negative 4 to positive 2. Okay. Now when I go to graph this in absolute value, these two pieces that fall below the x-axis have to flip up and become positive. So now, instead of going through negative 1, negative 4, we're going to go through negative 1, positive 4. And then we still keep that same triangular shape. So this bottom piece, no longer here when I graph in an absolute value. And then same thing, normally we go through 4, negative 2, but in absolute value, this is going to flip up and it goes through 4, positive 2. But still has the same triangle shape. Okay. And when we go to find the domain and range, the domain is still exactly the same, but our range now starts at 0, and the biggest y value we have is 4. So it's from 0 to 4. So pretty much this absolute value affects those y values. You can look up rules for exactly how to find it, but again, just think about graphically what this is doing and use that graph to find the range. Okay. So now that we have a little bit more of a hand with these absolute values, let's go ahead and just talk about some properties, and then we're going to utilize this to solve equations. So our first property is whenever you take the absolute value of any real number, it's always going to result in something that's greater than or equal to 0. I'm never going to take the absolute value of something and have it equal -1. It's not going to work out. Then in the same kind of manner, if I take the absolute value of a negative number, it's exactly the same thing as the absolute value of a positive number. So think of this with an example. If you take the absolute value of -2, it's 2. And it's exactly the same thing as the absolute value of +2. So both 2 and -2 give you exactly the same output for the absolute value function. Okay. When we take the absolute value of the product of two things, you can separate it and take the absolute value of each separately. And same thing with division. You can take the absolute value of the numerator, divide it by absolute value of the denominator. Only in that case that the denominator is not equal to 0. So essentially the absolute value is going to split for multiplication and division. However, it does not split for addition. So I can't say the absolute value of 1 plus 3 is the same thing as 1 plus 3 in absolute value. This isn't always going to be a true statement, so we don't want to do that. And the easiest way you can think of it is make one of these negative. If you try to take the absolute value of -1 plus 3, if you go through each of these side by side, you don't get the same thing on either side of the equation. So the absolute value does not split for addition or subtraction. Okay. But what this is really important for is when we're dealing with equations. So again, a lot of the methodology of our book is we're going to learn about particular functions, then we're going to learn about the graph of those things, and then we're going to deal with solving equations and solving inequalities. So we're seeing that right now with these absolute values. We've learned about the function, we know how to graph it. Now what we want to do is we want to try to solve equations, and then we're going to transform that to inequalities and see how we can utilize the same concepts there. So what I want to do is I want to think of a simpler absolute value equation. If we try to take the absolute value of x and need it to equal 3, we really have two solutions. So think about if I plug +3 in for x, the absolute value of +3 is 3. But if I plug in -3, I also get exactly the same thing. So both 3 and -3 are solutions to this equation. So when we're dealing with absolute value equations, there's a good chance we're going to have two answers. So anytime you have the absolute value of something equals a constant, you want to split it down and you can drop the parentheses or drop the absolute values, and then you can drop the absolute values and make one of them negative. But this only works when we say the absolute value of an expression is equal to 0, 1, 2, 3, 1/2, whatever it is. But remember, the absolute value can never equal something negative. Okay. So let's try a couple examples. We want to solve each of these equations for our variable x. So what x can I plug in to make this a true statement? So for our very first one, we have the absolute value of 2x plus 1 equals 17. So again, I should get two answers to this. One of the answers we find by just dropping the absolute values. Let's solve when the inside equals 17. The other option is going to come from saying this inside equals -17. Okay? And I will check for both of these just so we can see that, yes, we do get a true statement. Okay? And then both of these I solve in exactly the same way we've been doing before. We go ahead and subtract 1. That gives us 2x equals 16. And then we divide by 2. And we get one solution, x equals 8. For the second one, same process. Go ahead and subtract 1. That gives us 2x equals -18. And then we go ahead and divide both sides by 2, and we get another solution, x equals -9. Okay. So it's really natural at this point to just stop because you've gotten solutions, you don't need to do anything else. What I would highly recommend is checking your answers on this, because there is, what I don't want to call it a trick situation, but something that needs us to recognize something important about absolute values. And in that testing moment, you might totally forget this happens. So if you go and check your answers, it might be a way for you to see that, oh, I'm in this particular case. This didn't work out as I expected to. So I do want to check both of these, and I'm going to squeeze this up here just purely because I'm running out of room. If I plug x equals 8 in, I should get a true statement. So this would be the absolute value of 2 times 8 plus 1 equals 17, which is the absolute value of 16 plus 1 equals 17. And indeed, the absolute value of 17 equals 17. So this first solution is good. Okay. Now, let's erase all of this. Now let's try the other solution. If we plug in negative 9, this would be the absolute value of 2 times negative 9 plus 1 equals 17, which is the absolute value of negative 18 plus 1 is 17. And that tells us the absolute value of negative 17 is 17. Also a true statement, so this is our second good solution. Okay? So again, not 100% necessary, but you're going to see in a few examples that this could come in and save our butt from getting a problem wrong. All right? So let's try this next example. Now I have kind of an equation with extra steps into it. So it's not quite what we had in this first example. So I have the absolute value minus something equals 5. Remember when we've been solving equations, a lot of times we've had to isolate that variable. It's really the same kind of thing here. Before I can just drop the absolute values, I need to get the absolute value by itself. So you always want to isolate your absolute value expression with whatever it has in the middle. So in this case, the way we can do that is we can go ahead and we can add 2 to both sides. So this leaves us with the absolute value of 3x minus 1 equals 7. And now it's set up in the same way as the prior problem. I can go ahead and say, okay, the inside's exactly 7, or the inside has to be negative 7. So we get to drop the absolute values, and then we also get to drop the absolute values and make it negative. And then both of these I solve in the same way. We go ahead and add 1 to both sides. That gives us 3x equals 8. And then when we divide both sides by 3, we get the solution x equals 8 over 3. Not a pretty solution, but it is definitely a solution. Okay. Doing the same thing over here, we go ahead and add 1 to both sides. This gives us 3x equals negative 6. And then we divide both sides by 3, and that leads us to a second solution of x equals negative 2. Okay. And again, plugging these back in, definitely a good idea to check, but purely for time's sake, these two solutions work. So I've got one more here, and this is the one that I'm talking about that isn't quite a trick, but it's definitely going to take some more intuition and thought process to realize what's going on. So once you kind of learn an algorithm to solve some kind of problem, it's really easy to get stuck into the swings of that. So I see this is an absolute value equation. I've got the absolute value by itself. Super natural for me to just jump in and do exactly what I've been doing. So I'm going to start by going this route because, again, it's something that's really kind of natural as you go along in your homework. So you can go ahead and say, okay, let's drop the absolute values, solve this equation, or we drop the absolute values and we change the sign. So we make the other one the opposite sign. I'm going to get solutions for this because I can solve both of these. We go ahead and subtract 1. That gives us 3x is negative 6. And then divide both sides by 3. we get x equals -2. And then exactly the same thing on this side. Let's go ahead and subtract 1. And that gives us 3x is equal to 4. And then we go ahead and divide by 3. And we get x equals 4/3. Okay. So super easy to follow exactly the same pattern. I've got solutions. I think I'm done. But let's check that these work out. So let's start by plugging in x equals -2. If we do that, that gives us the absolute value of 3 times -2 plus 1 equals -5. That's the absolute value of 6 plus 1 is -5. And this tells us the absolute value of -5 is -5. And unfortunately, that is not a true statement. The absolute value of -5 is +5. So I actually end up with a solution that doesn't work, okay? And same thing if I tried 4/3. If I plug that back in, we have 3 times 4/3 plus 1 in absolute value is -5. When you go ahead and simplify that, those 3's cancel. We get the absolute value of 4 plus 1 is -5. And this tells us the absolute value of 5 is -5. So again, this solution is also not true. So really nothing works. There is no solution to this problem. Okay? And really, I didn't need to go through any of this work to do that. Because looking at this starting equation, I could have said right from there that nothing is going to solve this. Because this tells me that the absolute value of something equals a negative number. That is impossible, okay? So no work involved. I know right away nothing is going to solve this because the absolute value can never equal anything negative. So again, this is why I don't like calling it a trick. It's really about understanding the absolute value function, and understanding its output is going to be something positive or 0. Its output will never be anything negative. So you can go through the work, you can get your answers, and you can check them to see that they don't actually work out. Or right from the get-go, I can make this recognition and say, cool, I'm done. This is an impossible thing. It does not work out because of the way this function is defined. Okay. So now that we've got a little bit of a hand going through equations, let's try to take it up a notch and go through inequalities. So one of the things you're going to notice in all of our sections is once we learn about a function, then we solve equations involving that function, and then we solve inequalities about that function. Pretty much from here on out, so this is going to be one of our special cases that every absolute value inequality we can immediately turn into a different one that we can solve. But in reality, for our other sections, what we're going to have to do is instead solve the resulting equation, and then we have to interval test from there. So what I'm going to do is I'm going to show you first how these inequalities can break down, and then we'll apply that to an example. And then I'm going to show you the more general approach. It's really up to you what you feel comfortable doing. I don't have a preference within your homework. If you feel comfortable figuring out how each of these translate, absolutely use that method. But I do want to show you this just because it's going to make your life a little bit easier in the rest of the sections. So really just the way we break this down depends on where that inequality sign is facing. Is it facing towards the absolute value expression, or is it facing away? Based on that, it breaks down into one of two things, okay? And so what I'm going to do is I'm going to work with specific numbers, but you can look in the notes and you can see a more general approach. I think it's just easier to think of a very specific example first. So let's work with the absolute value being less than some constant, okay? In this case, think in your head about numbers that would work. If I plug in 2, the absolute value of 2 is definitely less than 3. If I plug 0, the absolute value of 0 is definitely less than 3. If I try to plug 4 in, this is where I run into a problem. That does not work. But also negative numbers are going to work. Because if I take the absolute value of negative 2, it's positive 2, and that's definitely less than 3. And same thing if I take the absolute value of negative 1, that's also less than 3. So not only do you have positive values that work, but we also have negative values too, okay? And so thinking of this with the equations, remember when we were solving the equations, we could exactly drop the inequality, or drop the absolute values, and we get one inequality that x has to be less than 3. Or I have to change the sign on the constant. But remember, when you're dealing with inequalities, when you change the sign, it causes that inequality to switch. So instead of going in this direction, it's actually going to go in the opposite. And really, that's exactly what this piece tells you. So we can always break down an absolute value being less than something by sandwiching it between the positive and negative version of itself. Okay? And the only thing that changes when you have that bar underneath is then you can equal these two endpoints. Okay? In the flip case, when I have the absolute value of x is greater than 3, now the numbers that are going to work for here, like 4, 5, 6, because the absolute value of 4 is definitely greater than 3. The absolute value of 9 is greater than 3. These both work. And same thing if I plug negative 4 in, it makes that positive 4, which is greater than 3. So negative values work here as well. And so when I break down this inequality, again, same thing. I can immediately drop the absolute value and I get x is greater than 3. Or I have to change the sign and make it negative, but then I have to flip the inequality. And so that gives us this second portion. Okay. In terms of number lines, for this first one, the x values are trapped between negative 3 and 3. Can't equal these endpoints, but everything in between is good. And then here, the only difference is now I can actually fill in these circles. So I can fill in here, and I can fill in here. Okay. When we deal with this other inequality, instead of filling in between, we're going to fill in the values on the outside. So I can equal everything over here and everything over here. And then the second we add the bar, all it does is it fills in the endpoints at negative 3 and positive 3. Okay? But in the same way we had issues with our equations, you've got to first pay attention to the expression that's given to you. The absolute value will never be a negative number. So if I'm trying to say the absolute value is less than a negative value, it is not going to happen. Okay? So let's try a couple examples. For this first one, I'm going to do it exactly in the same way as above. We're going to break down the inequality that we have. So we are told the absolute value of 3 minus x is less than 2. So in one instance, I get to exactly drop the absolute values. And then I go ahead and change the sign, but then the sign has to flip as well. So the absolute value being less than something sandwiches it between negative 2 and positive 2. And then from here, I go ahead and I solve. So I need to get the x on its own. So we go ahead and subtract 3 from everything. This gives us negative 5 on the left, negative x in the middle, and negative 1 on the right. And then again, to get x by itself, I've got to divide by negative 1, but because we divide by a negative number, we have to flip the sign. So we get 5 is greater than x is greater than positive 1. So we need to put our solution in interval notation. 1 and 5 are our two key numbers. I don't have that bar, so I can't fill in these endpoints, but I can take all x values in between. So in interval notation, this would be from 1 to 5, okay? We can still check our answers here because only the stuff in this interval would work. So I could test something from each one, which is actually what we're going to do for the other problem. So we have interval 1, 2, and 3. If I pick something from interval 1, like 0, it should not satisfy the inequality. This would be the absolute value of 3 minus 0 is less than 2. The absolute value of 3 is not less than 2. So this interval does not work, and that's good. That's exactly what I have based on my graph. If we pick something from interval 2, 2 is a number between 1 and 5. So if I plug that in, that's the absolute value of 3 minus 2 is less than 2, which is the absolute value of 1 is less than 2. Indeed, the second interval works, so that is a solution. And then finally, if I pick something from interval 3, like 6, this interval should not work. So that gives us the absolute value of 3 minus 6 is less than 2, which is the absolute value of negative 3 is less than 2. And again, this interval is no good. So just that second interval is the one that works, anything between 1 and 5, which is exactly what we got from just breaking it down, okay? So this is one method you can use to solve these inequalities. For this next one, this is that particular situation. I could try to do the same thing. So if I went about solving this, I would go ahead and drop the absolute values, and then I would have to change the sign. And then if I went and tried to solve this, I would add 2 to everything. This tells me that x is greater than 3, but it is less than 1. And this makes 0 sense. X cannot be tracked between 3 and 1 in this manner. So this actually has no solution. And again, that's something I could recognize just from the very first statement. So I'm saying the absolute value is less than a negative number. This cannot happen. Okay? The absolute value will never be something negative. So your solution in interval notation would just be the empty set. No value of x is going to work. Okay? So I have one more problem. What I want to do is I want to solve this one in a different manner than what we did before. So instead of trying to break it down into two separate inequalities, what I'm going to do is I'm going to solve the resulting equation. So we're going to solve, where does the absolute value of 4 minus 3x minus 3 exactly equal negative 2? And this will give us our important numbers. So again, we've got to isolate that absolute value, and it gives us the absolute value of 4 minus 3x is equal to 1. So we get two solutions. The absolute value of 4 minus x is 1, or the absolute, or just 4 minus 3x is equal to negative 1. Okay? And then each of these I would solve. We go ahead and subtract 4, and I'm going to solve both simultaneously. This gives us negative 3x is equal to negative 3. And here this is negative 3x is equal to negative 5. And then we divide this side by negative 3. Same thing over here. We get one solution, x equals 1. And then we get a second solution, x equals 5 over 3. Okay. So these are our two important numbers. So I'm going to graph them on our number line, 1 and 5/3. And we can actually equal these endpoints because we have greater than or equal to as our inequality. So we can fill these endpoints in. Okay. And what this has done is it's broken down my number line into 3 intervals that we need to test. So from our first interval, I want to pick a number that falls in there, and 0 is always a good option. 0 would fall in this interval. So if we plug that in, that would be the absolute value of 4 minus 3 times 0. Minus 3 is greater than or equal to negative 2. This would be the absolute value of 4 minus 3 is greater than or equal to negative 2. And that's just 4 minus 3 is greater than or equal to negative 2. And indeed, we end up with something that is a true statement. So that tells us this interval is good. If I move on to interval 2, a number that falls between 1 and 5/3, unfortunately, is not going to be a pretty number. 5/3 is about 1.67, 1 2/3. So I'm going to have to unfortunately pick a decimal. Let's pick 1.5. That would fall between 1 and 1.6. So this would be the absolute value of 4 minus 3 times 1.5. And then minus 3 needs to be greater than or equal to negative 2. So this is the absolute value of 4 minus 4.5 minus 3 is greater than or equal to negative 2. Which gives us the absolute value of negative 0.5 minus 3 is greater than or equal to negative 2, which is 0.5 minus 3 is greater than or equal to negative 2, which is really, gotta squeeze this in here, negative 2.5 is greater than or equal to negative 2. And unfortunately, that is not a true statement, so this interval does not work. And then last but not least, we move on to interval 3. 2 would fall in there, so we got to see if it works. So this gives us the absolute value of 4 minus 3 times 2 minus 3 needs to be greater than or equal to negative 2. So that's the absolute value of 4 minus 6 minus 3 is greater than or equal to negative 2. Absolute value of negative 2 minus 3 is greater than or equal to negative 2. And indeed, we end up with something that is a true statement because this is saying 1 is greater than or equal to negative 2. And that does work. So interval 3 is good. So our solution to this inequality is 2 intervals, which makes sense because we have the absolute value is bigger than something. So it breaks down into the 2 separate intervals. And the first interval is from negative infinity up to 1. And then from 5/3 onwards to infinity. Okay. So if you want to see another way to do this, you can go ahead and look in the notes. You can just break it down using this definition we have up here. So just to kind of show you for that, the other way you can do this problem is you have to isolate the inequality or the absolute value. So it'd be the absolute value of 4 minus 3x is greater than or equal to 1 because you have to add the 3 over. And so you get to immediately drop the inequality, and then you also need to change the sign, but you've got to flip the sign in the middle, okay? And then you could solve these 2 resulting inequalities, and you would see you end up with exactly the same thing. So both work, completely a personal preference for you. But again, moving forward, this is going to be our more general approach where we instead solve the resulting equation.